Whenever we're browsing the web, we're basically the customer, right? We click on things, we make requests, and poof, a web page appears. But have you ever wondered what's really going on behind the curtain? Well, today, we're going behind the scenes. We're stepping into the kitchen to meet the manager.
Seriously, think about it. When you type in a web address and hit enter, who or what is on the other side of that connection? Who's answering that call, taking your order, and bringing you back the exact page you asked for? Well, it turns out there's this incredibly dedicated manager working 24/7, just waiting for you. And that manager is the web server. If a website is like a big digital restaurant, then the web server is the head waiter and the general manager all rolled into one. It's a piece of software, and its entire job, its only purpose really, is to listen for your browser's order, go find the right files, and serve them up to you.
Okay, so let's get into this, because it's actually pretty cool. A web server is really two things at once. First, there's the hardware, the physical computer where all the website's files are stored. You can think of that as the actual restaurant building. But then there's the software, the program that runs on that computer. That's our manager.
So what does this manager actually do all day? I mean, what does the job look like? Well, it all boils down to a really simple 4-step cycle that just repeats over and over and over again. This whole process kicks off when the server has to listen. It's just sitting there, kind of like a waiter by the door, just waiting for an order to come in. That order is called an HTTP request from your browser. Second, it has to understand it. Okay, this person wants the About Us page. Got it. Third, it has to find it. It zips back into the kitchen, the server's hard drive, and grabs that specific file. And finally, step 4, serve. It sends that file right back to your browser as what we call an HTTP response. And that little 4-step dance, listen, understand, find, and serve, that's not just some minor detail. That is the fundamental engine that powers the entire web. Every single web page, every image, every video you've ever seen online happened because of this cycle.
Now, just like in the real restaurant world, not every kitchen is run the same way. You've got different management styles, different philosophies, and you know what that leads to? Competition. Some pretty serious competition, actually. In fact, this isn't just a friendly rivalry. The market is absolutely dominated by two giants. Together, these two run more than half of all websites on the entire planet, and their names are Apache and NGINX. So to really get a feel for them, let's go back to our restaurant metaphor. Let's think of Apache as a classic, versatile American kitchen. You know, the kind of place that can make a great burger, a salad, some pasta. It's flexible. It does a bit of everything. NGINX, on the other hand, that's the sleek, modern sushi bar. It's built for one thing above all else: hyper-efficiency and speed. See, Apache's whole model is basically to hire a dedicated waiter for every single customer that walks in the door. This is awesome for flexibility, because each waiter can give that customer their full attention. But you can probably see the downside, right? If 1,000 customers show up at once, you suddenly have 1,000 waiters running around. The restaurant gets crowded and things can really slow down. NGINX completely flips the script. Instead of a waiter for every customer, it has one super fast manager at the front door. This is called an event loop. That one manager takes all the orders from every customer and then efficiently passes them off to a small, skilled team of cooks. This whole system is designed from the ground up to handle a massive number of people at the same time, without even breaking a sweat. So let's put them head to head. When we look at their architecture, Apache's process per request model is amazing for flexibility in all its available modules. But its resource use can get pretty high. NGINX's event-driven model is just ridiculously efficient, which makes it perfect for sites with high traffic, especially for serving static files like images. And they're not the only ones. Other servers like Lightspeed use a similar event-driven approach, kind of like a racing car built for pure speed. And you can really see that dominance when you look at the actual market share. It's wild. Apache and NGINX are just these massive players, managing huge slices of the entire web, while other competitors are also carving out their own space in this constant battle for efficiency. Okay, so this is all really interesting, but how can you actually use this knowledge?
Well, the best way to truly understand how these things work is to build your own. It's time to set up your very own experimental restaurant.
And this is where a local server comes into play. And it's exactly what it sounds like, a web server running right there on your personal computer. It becomes your safe, private test kitchen, a place where you can build, experiment, and break things without anyone on the public internet ever seeing it.
To get your kitchen set up, you basically have two main options. You can go the easy route with package tools like XAMPP or WAMP. These are like a restaurant-in-a-box kit. One click and it installs Apache and everything else you need. Or, if you want total control, you can go the build-your-own route and install something like NGINX yourself. It's more work, but you learn a ton.
All right, so we've met the manager, we've seen how the different kitchens are run, and we even know how to build our own little test kitchen. But there's a catch. So far, our restaurant can only serve food from a fixed, pre-printed menu.
So what happens when a customer comes in and they want something that's not on the menu? What if they want a custom-made dish, something created just for them on the spot? And this is where we find the natural limit of what a web server can do on its own. They are absolute masters at serving what we call static, ready-made files, things like HTML pages, CSS files, images. But for dynamic, custom-ordered content, things like your personalized Facebook feed or the latest blog posts from a database, for that, our waiter needs to get help from the professional kitchen in the back. So if our web server is the manager and the waiter out front, then who are the chefs? Who's actually in that professional kitchen, cooking up all the dynamic, personalized content that makes the modern web feel so alive? Well, that is the perfect question for our next explainer.